Hi everyone, welcome to the classes on engineering mechanics. Today we will be discussing on motion of rotation. This is our second class on motion of rotation. We will be discussing few more problems in connection with the motion of rotation. In the previous class we had discussed that the motion of rotation is almost similar to the linear motion. We will be using the same equations that we are used in the linear motion, that is equal to for S is equal to ut plus half at square and v square minus u square equal to 2as and v is equal to u plus at. We will be just replacing with omega, alpha and theta instead of v, u and s and acceleration a. Okay, we will go to our first question. A shaft is uniformly accelerated from 10 revolution per second to 18 revolution per second. So it's given initial velocity is 10 revolutions per second and final velocity is 18 revolutions per second. So one revolution is equal to one complete rotation, that is equal to 360 degree, can be written as 2 pi. So 10 revolution can be written as 10 into 2 pi, that is 20 pi is the initial velocity, and the final velocity 18 into 2 pi, that is 36 pi is the final velocity. So and this is happening in 4 seconds. The time taken is 4 seconds. The shaft continues to accelerate at this rate for the next 8 seconds also. So total 4 plus 8, 12 seconds it is in the acceleration motion, and thereafter the shaft rotates with a uniform angular speed. Find the total time to complete 400 revolution. Again we will be converting revolution into 2 pi. 400 into 2 pi will be 800 pi is the distance traveled, that is theta is given as 800 pi, or in our linear motion we will be rewriting s. So we will be writing the given data. Initial velocity 10 revolutions per second, that is equal to 10 into 2 pi, 20 pi radians per second. Final velocity 18 revolutions per second, that is equal to 36 pi radians per second. And we will have for the initial 4 seconds it is having an acceleration, and for the next 8 seconds also it will have an acceleration, and the remaining time it will remain its angular speed. We have to calculate how much time it will take to complete 400 revolutions. First we will calculate the acceleration using the data initial velocity, final velocity and time. V is equal to u plus at. So instead of v and u we will be using omega and omega naught. Omega is the final velocity, omega naught is the initial velocity. So omega is equal to, that is 36 pi is equal to omega naught plus alpha into t. Omega naught is the initial velocity, that is 20 pi. Alpha is unknown. The time is taken 4 seconds. So we can calculate the value of alpha as 4 pi radians per second square. Okay, and it will continue this acceleration for the next 8 seconds also. So by using the initial equation we can calculate the initial velocity and the distance traveled. We will be dividing the total distance traveled into theta 1, theta 2, theta 3. For the first 4 seconds theta 1, for the next 8 seconds theta 2, and the remaining will be taken as theta 3. So we will calculate the first value of theta 1, that is theta 1 is equal to omega naught ut plus half at square, or omega naught t plus half alpha t square, where omega naught is the initial velocity, that is 20 pi into t. Time taken is 4 seconds for the first portion 4 seconds, second portion 8 seconds, and remaining so t is equal to 4 seconds. We will be getting the initial distance traveled is equal to 1112 pi. And for the next 8 seconds again it continues its acceleration. So it's final, now its initial velocity, so already traveled for 4 seconds, so initial velocity is changed from 20 pi to 36 pi. For the next theta 2 we will be using the initial velocity as 36 pi. 36 pi into h plus half into 4 pi into h square. This is the for the second section, that is theta 1 for the first 4 seconds, theta 2 for the next 8 seconds. So this is the total distance traveled by the first 12 seconds. We have to travel 800 pi distance. The remaining it should be traveled by a uniform velocity. Now its velocity is increased from 36 pi to a higher value, which can be calculated using the equation v is equal to u plus at, or omega is equal to omega naught plus alpha into t, where omega naught is equal to 36 pi, alpha is equal to 4 pi, and for a duration of 8 seconds we will get the velocity after 12 seconds, that is equal to 68 pi. The body will continue its uniform velocity for the remaining. The remaining distance it have to travel can be obtained by subtracting 112 pi and 416 pi from the total distance to be traveled. So the distance to be traveled is 272 pi. So this will be traveling with a uniform velocity 68 pi. So time taken can be obtained by 272 pi divided by 68 pi is equal to 4 seconds. So we have to calculate the total time taken for 400 revolution. For the initial 4 seconds, it has traveled 112 pi. For the next 8 seconds, it has traveled 416 pi, and the remaining distance is traveled by 4 seconds. So total time duration is equal to 4 plus 8 plus 4, 16 seconds. Okay, we'll go to our next problem. A swing bridge turns through 90 degree in 120 seconds. Swing bridge is nothing but a bridge can be open and closed for the travel across a river. Sometimes it will open for the ship to travel, for the passenger car or lorry to travel it will be remains closed, just like our railway cross. Okay, a swing bridge turns 90 degree in 120 seconds. So it's traveling, theta is given by 90 degree. So 90, one complete revolution is equal to 2 pi. 90 degree means quarter revolution, that is it's traveled only 1/4 of the total revolution. For traveling a complete revolution we will have 2 pi. For traveling a 1/4 of revolution we will be having a theta is equal to 0.5 pi. The bridge is uniformly accelerated from rest for the first 40 seconds. Initially it is accelerated and subsequently it turns with a uniform velocity for the next 60 seconds. So out of 120 seconds, for the first 40 seconds it is accelerated. For the next 60 seconds it is in uniform motion. Now the motion of the bridge is uniformly retarded. Finally the bridge has to be bring back to stop at the 90 degree position. So it has to retard. For the next 20 seconds the bridge is in a retardation motion. So we have to calculate the angular acceleration, maximum velocity and angular retardation. So we will be writing our values. Angular displacement, that is 90 degree, can be obtained by quarter of the one complete revolution, that is equal to 0.5 pi. And we will denote alpha 1, alpha 2 as the angular acceleration of the bridge and angular retardation of the bridge. And we will be noting down the time taken for initial acceleration 40 seconds, uniform velocity 60 seconds and final retardation 20 seconds. And we will be writing the equation for first 40 seconds. S is equal to ut plus half pi t square. We don't know the value of initial velocity is 0 because it is starting from the rest. We don't know the value of acceleration. So we will be writing ut, that is 0 into t, that's equal to 0 plus half into alpha 1 40 square, where 40 is the time taken for the first portion. Initially it is in the acceleration motion. So S can be written as 800 into alpha 1. Okay. For the next portion it will be in a uniform velocity. The uniform velocity can be written as v is equal to u plus at, where u is the initial velocity. It is starting from rest. So u can be written as 0 and alpha can be written as alpha 1 and time is 40 seconds. So velocity obtained at the end of the first 40 seconds is equal to 40 alpha 1. This is its uniform velocity after 40 seconds. And for the next 60 seconds it will have the velocity 40 alpha 1. So distance traveled by the next 60 seconds is equal to 40 alpha 1 into 60. That's equal to 2400 alpha 1 will be the distance traveled for the next 60 seconds. So initially it has traveled 40 seconds with an acceleration. For the next 60 seconds it is traveled with a uniform velocity. That uniform velocity can be calculated by using the equation v is equal to u plus at. Okay. Then the remaining it has a retardation. So retardation, after retardation the bridge is back to its rest position, that is velocity equal to 0. So we can write final velocity of the bridge is 0 after 20 seconds. Initial velocity is 40 alpha 1. Now the velocity of the bridge is 40 alpha 1. So we can using the equation v is equal to u plus at, we can write the value of alpha retardation in terms of alpha 1. So we will be writing final velocity is 0, initial velocity is 40 alpha 1 and retardation is alpha 2. So we will be writing alpha 2 in terms of alpha 1. And for the third portion we will be writing the equation of theta is equal to ut plus half a t square, where u is the initial velocity 40 alpha 1, t is the time taken 20 seconds, minus half a t square, half into alpha 2 into time taken is 20 seconds. The alpha 2 can be replaced with alpha 1. We will be replacing alpha 2 with 2 alpha 1. So we will obtain the equation as 400 alpha 1 is our equation. Theta 3. So initially 800 alpha 1, second portion 2100 alpha 1, and third portion 400 alpha 1. This is the total distance travelled by the bridge, which is equal to 0.5 pi. So we can calculate the value of alpha 1 as 0.0436 into 10 raised to minus 3 radians per second square. Okay. And the first angular acceleration we have calculated. Next we have to calculate the maximum velocity. Maximum velocity is written here. It is 40 alpha 1. 40 into, we know the value of alpha 1. We can write alpha 1 is 40 into alpha 1 is equal to 17.44 into 10 raised to minus 3 radians per second square. And third thing, we have to calculate the value of alpha 2. We have got the relation for alpha 2 in terms of alpha 1. So we will be writing the value of alpha 2 in terms of alpha 1. This is our value of retardation. So we have calculated all the required values.